Welcome to my class. In the previous video, we had learned about a graphical representation of motion. Okay, and that was quite easy for you. I know that. Now, to understand the equations, okay, or to solve the numericals, we need equations. So to solve the equation, we need to solve the numericals, we need equations. But if we don't understand the equations from where it came, then it will be very difficult for us to understand. Okay, and on top of that, many people find physics hard, but it is not. Actually, physics, we have to think, or we should have a very good visualization to understand physics. Okay, it is everywhere and we just have to concentrate on what we are doing. Then it will be very easy for us to understand it. Okay, now to make it more clear, we'll start first with equations of motion by graphical methods. Okay, in this graphical methods, we have three equations. The first one is for velocity time, second one is for position time, and the third one is for position velocity. Okay, so the first one, let us try to understand it. Okay, so equation for velocity time relation. So we are just trying to find a relation in between velocity and time. What exactly is there? Okay, so to understand that, first let us consider this graph where on the x-axis we have time, on the y-axis we have velocity, and here this OA is your initial one and this cbse is your final one, velocity. Okay, to derive the first equations, that is v equals to u plus at, let us consider the velocity time graph of the body. The body has an initial velocity u at point A. So here there is an initial velocity. Okay, and its velocity changes at uniform rate from A to B. Can you see from here? Uniform means straight line is there. So straight line means uniform motion or uniform velocity. Okay, so in time t, how much time it has taken? Time t. Its final velocity becomes v. So this is your v, okay, which is equal to b. So here it is b. In the graph, the time t is represented by OC. Now this is your OC. Okay, to make it more clear, let's write t here. This is your time. Okay, so to come now here, equal to b in the graph. The time t is represented by OC. To complete the figure, we draw a perpendicular BC from C. So here it is, and draw AB parallel to OC. Let's write here AD. Okay, this is not B, this is AD parallel to OC. And BE is perpendicular from B to OE. Now in this graph, what happens is initial velocity u is how much? OA. So this is your initial one, and this is the OA is your initial, and final is V, that is BC, the total one, right? So from the graph we have BC equals to BD plus CD. Let us go out here. So BC means it is BD plus CD, BD plus CD, or V, BC is your V, and BD plus this CD actually means U, because this is your OA and CD are equal, and this will give you U. So then when this U will come the side, it will become V minus U is equals to BD. Okay, now therefore acceleration A is equals to slope of the line AB, okay, and AB will be equals to BD by AD, this is your BD and this is your AD to find this slope. Okay, so here we have A equals to BD by AD. We can say this AD as time, because OC is time and OC and AD are equal. Okay, So putting the value of BD in equation 4. So there is your equation 4. So if I'll put it out here, what I'll get? Putting the value of BD in equation 4, we get V equals to U plus AT. Now look at here. The first thing, to derive V equals to U plus AT. So this is your V equals to U plus AT. Now this equations is the relation with the velocity and time. Velocity and time. V, U, A and T. V, U, A and T. So if there is no displacement, only there is initial velocity, final velocity, time and acceleration. If any of the three is given to you, you can use this equation to solve the numericals of this chapter. Okay. And in the next one, we have in the second equation as for position time relation. Position time relation. To derive S equals to UT plus half AT square. This is the second equation. That is for position time relation. Okay. Let us say the body travels a distance S in time T. The distance traveled by the body is given by the area of the space between the velocity time graph AB. So look at the graph here, AB. In this ABCO, here this area we need to calculate the find this equation. Okay, so AB and the time axis OC. So this is your time axis. This you can write out here T, time. Okay. So which is equal to the area of figure OABC. OABC. Okay. So let us try. Distance traveled is equals to area of figure OABC. Area of OABC. You can see here very clearly there is one triangle and here is one rectangle. Okay. So it is area of rectangle plus area of triangle. If I will put the value of this two, I will get the equation second. Okay. So as distance traveled is as equals to area of rectangle, length into breadth. So this is your breadth, this is your length, U into T. U into T plus half into AD. Where is our AD? This is our AD. AD is equals to T. So I'll write T here and BD. BD is how much? Here you got this BD, right? BD equals to V minus U. BD equals to V minus U. Okay. So from the equation 1, V equals to U plus AT, V minus U. When I'll take it minus this side, it will become AT here. So V minus U, instead of V minus U, I can write AT. So I'll replace this V minus U by AT. Okay. Then what it becomes is S equals to U into T is UT plus half A T into T is T square. So this will give you second equations. That is to calculate the displacement, acceleration, time and only the initial one, initial velocity. Then we can give this equation to solve the numericals. Okay, this gives you the position, time, position and time. Okay, this is for your position, time. Now the third equation we have is equation for position velocity relation. Position velocity relation. Okay, here also we'll try to find out the S. Okay, so the distance S is the distance covered by the body in time T. Or look at here in this graph, what do we have is OACD is there. So this is a four-sided closed figure with one parallel side. Okay, it means that this is a trapezium. So if I will calculate the area of this trapezium, I will get the equation of position velocity. Okay, so is equals to area of trapezium OA CD. Fine. Now look, S equals to, what is the area of trapezium? S, or we can say the area of trapezium is sum of two parallel side into height into half. So here half sum of opposite this parallel side into height okay. So it is half sum of opposite side. So OA and CD are parallel to each other. So I'll write OA plus CD into height. So when I look at like this, the height will become this AB. It is perpendicular. So this AB means equal to T. So I will be doing it with half OA plus CD into AB. Half OA means U and CD means V. This is your OA. From here to here it is U, and from D to C it is V. So half U plus V into AB is T. Now look at here. S equals to half V plus U is this one. Now T. From equation 1, what we have is V equals to U plus AT, and when this plus U will come this side, it will become minus, and this A is in multiplication. When it comes this side, it will become divide. So V minus U by A is T. So I will replace this T with V minus U by A. So T, I'll replace it with V minus U by A. Then what it becomes is 2 into A into S. This is in the denominator part. So when it goes this side, it will multiply. Okay, 2 into A into S is 2AS. Then B plus U, B minus U. It means A plus B, A minus B is equals to A square minus B square, or B square minus U square. So this equation will become B square minus U square equals to 2AS, or B square equals to U square plus 2AS. This will give you the position velocity relation. Okay, I hope you got it. If you have any doubts, you can just comment below. Okay, and I'll try to make your doubts clear. Thank you. We'll see you in the next video. Okay, bye everyone.